Subsetting is the most common type of data manipulation. It's also called indexing or subscripting. In other words, it involves extracting elements from an R object, for example, a vector, matrix, list, or even a data frame. To do this, we use the bracket notation. Here we have single square brackets to access the elements of an R object. So let's look at an example. So we create here a name vector, and named in the sense that we have the names associated with the vector here. In our case, we have character vector here, and we give them meaningful names. Population, we have a character vector there, character vector. We can also access this named vector using the names function. We're going to see this in a short while. Okay. So how do we extract elements from our vector here? We can do this by first looking at the first method, subsetting by index. What this means, we subset or extract elements using the positional element of these vectors, 1, 2, 3, 4. So first we execute an empty. So first of all, let's execute our vector here, create our object X. Then we can execute here an empty. So that means we didn't specify anything. So we'll just output everything here. So let's say if we wanted to extract the first element, first we use the square brackets. First we use our existing object, use the square bracket, and we just pass the number 1. Okay. It just extracts or slices for us this first element. What if we just wanted to extract the fourth element? Again, we just pass the number 4, fourth element. What if we wanted to do second and third element? In this case, then we need to use the colon notation. So say from second to the third element, for example. When you do that, it just takes us, or rather extracts for us city and population together with the value. Okay. What if we just want to extract the last element, right? Or maybe we just want to exclude the last element. So we just say X, our object, and then minus. So we needed to know how many we have, 1, 2, 3, 4. So R starts at position 1. So we say -4. So -4 here will return country, city, population, and leave out zip code. We can similarly do the same if we want just to exclude the second and the third, say -2 here, colon, then -3. Okay. So that will just remove the insert part, right? So we'll just get us the country and the zip code. Okay. The other method is subsetting by name, right? So simply here, names are optional, but we can use the names function, right? So if we go ahead and execute our vector again, our object, then we invoke the names function. It just extracts us the name of our character elements, right? So the same thing we can do here, but this time around we use the names to extract the elements, right? So remember, we have here the names as country, city, population, and zip code. So we just pass that. Where we were using 1, we just use the character here, country, and just extracts for us the entire name and the value. Okay. So the advantages of using subsetting by name is that we don't have to worry about the positional element. So for example, here, X, our object X here, assuming that we always started with country. What if we have another object that doesn't follow the same rule? That means if you extract by index here, this object country will be the first element, and then city will be the first element. So if we use the named vector, we don't have to worry about that. We can just say country, right? Execute that. And we can also do the same for our object X1, right? We don't need to worry about, and every time we'll be able to extract that. Okay. Another thing is vector attributes. We can extract all the information, mostly the names of our vector. Okay. The same thing here, if we wanted to get both city and population, remember we were using vector, colon vector. With characters, we just separate that by a comma. So we get our city here for a name vector, a population. And remember here, we're using the C function to concatenate more than one characters, okay? Here also, we can do the same. What if we wanted to add names to our vectors? So here we can create a vector without names. Remember, this is an integer, okay? So we create that. In fact, I wanted to show you something here, a tip here. So one of the advantages of using integers. So let's say if you have a million, a very large value, right? Using integers will be memory efficient, and we can check by looking at the size, memory size occupied by this. So if we run this, you can see this is 64 bytes. If we just use numeric or double, right? Remove the L. Run that and see how many bytes is occupied in memory. You can see this almost 80 bytes. So that's one of the advantages. You know, if you want to just, if you're dealing with very large values, then using integers is the way to go. Okay. So now that we have that, how do we add names to our vector, a name vector? So first of all, let's create our vector like that. Then what we do here, on the right-hand side, we create the characters that we want to add, okay? Then we use this function names, right? Then we pass our object that we've created. So we're telling our, include this, automatically we'll know that we want to add names to our object here, X, using this function, names functions. What we want to add, we want to add this sequentially to our values here, 2L, 3L, and 4L. So when we run this, okay, and then we print our object here, you can see now it has some columns, first, second, and third. Then lastly here, we can subset by logical vector. So what we can do here is to go ahead and create a vector of elements 10, 20, 30, 0, 40, and 60. Okay, we can use the comparison operator, right? In our case here, we can use check or return whether it's true or false. So is X greater than 20? Run that. I will just return for us logical values, right? So where it equates as true, it will return true. So we'll keep on checking. So you can see the third element here is true. And so is the fourth, the fifth, and the last one. Okay. Other examples you can check here. So want to check if X, you can want to match exact element, right? So you can say X into brackets, and then you want to use comparison operator. So is X equals to, so here we use equal, double equal sign, right? In R. So we want to match exactly as that. So if we find a value to match, right? What if we don't find a value in our vector here, in our object? Okay. Or return numeric 0. Okay. Again, here we can combine. Here we just say, return all the values that match 20 and 60 or 60. So if both, then we'll return both. Okay. Or, so this is how we do or. But here it's impossible to return both. We use this and, so we're saying the same thing, but this would be impossible to return the same at the same time. But this would be possible. So we want to just use a range, return all values that are greater or equals to 10. So from here all the way to less than 40. So we'll just check anything less than 40, we'll return all this here. Okay. So we execute that, and that's what we have. Same here, we can return, anything less than 20 and greater than 40 using and. This would be impossible. Okay. Other functions here you can use is called the which, helps us to ask questions. So we use the which function, and then we just pass our object there, and comparison operator just say, is X greater than 30? If yes, it returns us the values that are actually, actually the positional elements that are actually greater than 30. How many are they? Okay. So, and you can confirm here, this is the third element is equals to 30, greater or equals to 30. Then we have the fifth and the sixth element. Okay. Same here, you can just say, hey, we want to find the minimum, not the mean. So we want to find in our vector here, get us the minimum value. Okay, that's how we do it, and returns that actually this is the minimum value. Where is that? So let's run this again. So if we run this again, so the minimum value is at position 4. So 1, 2, 3, 4, which is 0. Okay, and we can also find the positional element, right? And it tells us is the largest value is at position 60. Okay. Lastly here, what's the difference between a single and a double bracket? So with a single bracket, we get the name of the attribute. If we use the double brackets, okay, it drops the name attribute. That's just the difference. So here, again, let's create our object there. So let's say we wanted to access the second element. So I just pass there the number 2, and we get the city here as Detroit. Okay. Now, what if we just want to get the value Detroit? Then we can use a square bracket. So this will be very important when we start looking at data frames. So if I pass there 2, you can see it kind of just drops the named attribute. Okay. All right. And that's it as far as extracting elements from an R object is concerned.